11.4 is about probability. So we are going to compute theoretical probability and empirical probability. Let's recall some things with fractions. So simplifying fractions, you would need to find a common divisor for each of these. 18 and 24, you can divide by 6. You can also divide by 2 and 3, but the largest value that you can divide both of them by is 6. You divide both, and we get 3/4. You can also use your calculator to simplify fractions. If you have the update on your calculator, you can do alpha y equals. You can do 18 over 24 and then reduce it like that. Or if you don't have the update, you can do it like this and then hit math fraction and it'll put it back in the fraction form for you. Okay, multiplying fractions, you multiply top times top over bottom times bottom. So 5 times 1 is 5. 15 times 7 is 105. Then I see that they both are multiples of 5, so I'm going to divide by 5. And that's 1. 5 goes into 120 times, so we have one more, so that's 21. Another way to multiply fractions would be to cross simplify or cross reduce. So you could look at your diagonals to see if they have anything in common. These don't, but these do. So you could reduce by 5 to begin with. So this becomes 1. Reduce this by 5, and it becomes 3. So now we have 1 times 1 and 3 times 7. Same answer, just two different ways of doing it. Next one, top times top over bottom times bottom. These are big numbers. So you could look for a way to reduce it first, or you can use your calculator. But 7 and 17 are both prime, and 7 doesn't go into 17, but so that's not going to work. But 39 and 26 have a multiple of 13, or a divisor of 13. So we can reduce that by 13. 39 divided by 13 is 3. 26 divided by 13 is 2. So now we just have to multiply 3 times 17. So that's a lot smaller of a number to do with. And then, so it's 51. And then 7 times 2 is 14. If you want to put it in fraction form and multiply straight across like this in your calculator, you can do that too. I just want you to know how to do it by hand as well. My calculator just quit on me. Let's try this again. There we go. So that also works. All right, let's talk about what probability is. So probability represents the likelihood that something will happen, a certain event, okay? So you can assign values for probability from 0 to 1. So you can't have anything in the you can have a negative probability and you can't have anything above 1 as probability because we're also talking about chance, which we can think about that as a percent chance that something will occur. So probability of 1, or if you move the decimal over and make it a percent, we would have 100%. That's certain. It's 100% going to happen. Then as you go down your number line, you get likely. 50% is like a 50-50 chance, 50-50 shot. And then below 50 is unlikely, and 0 is absolutely impossible. So the closer the probability is to 0, the less likely that an event will occur. And then the closer it is to 1, the more likely it will occur. So there's two types of probability. We'll talk about theoretical, and we have empirical. So we need to know some vocabulary. So experiment is any occurrence for which the outcome is uncertain. So you conduct an experiment experiment to find the likelihood of certain outcomes. Sample space is the set of all possible outcomes of an experiment, denoted by S. Event, denoted by E, is a subset of a sample space. So let's say you want to find probability of whenever you flip a coin, you get heads. So the event would be heads. Sum of theoretical probabilities of all possible outcomes is 1. So whenever you add up all your probabilities, you should get 1 because that should be all of your sample space. Theoretical probability is denoted by P of E, number of outcomes in an event over total possible outcomes. So theoretical, the way I remember that is what should happen in theory. So in the perfect world, this should happen. So to find that, you would do number of outcomes for that event over all possible outcomes. Basically S, your sample space. So let's find the theoretical of rolling a dice. So it says it's rolled once, find the probability of rolling a 3. So we're going to list out all these sample spaces. 1, 2, 3, 4, 5, and 6. We want to know the probability to roll a 3. So probability of getting a 3. Well, there's only one 3 out of the sample space is 6. So 1 out of 6. Probability of rolling an even. So there are 1, 2, 3 evens. The probability of an even is 3 out of the 6. And then you would need to reduce it. Okay, example 2, probability in a deck of 52 cards. So a deck of cards is 52. We're not going to include jokers in this. The probability of getting a king. The probability of king. Well, how many kings are there? There's a heart, there's a diamond, there is clubs, and there's spades. So there are 4 kings out of the 52. So then you reduce it. The probability of getting a heart. So you have the 4 different types of cards. So you have heart, diamond, club, and spade. So there's 4 different types. In each, there are 13. So 13 hearts out of the 52, which is actually 1/4 of the deck, which makes sense because there are 4 types of cards. Okay, let's look at a 12-sided die. We want the probability of rolling a number less than 5. So what I would do is I'd go through and find all the numbers less than 5. So since it says less than 5, we do not include 5. So there are 4 out of the 12. You reduce that to 1/3. The empirical probability, it applies to situations in which we observe how frequently an event occurs. So this is what actually happens when you conduct an experiment. The empirical probability of an event is observed number of times E occurs over total number of observed outcomes. So you look at your sample space. So in this case, your sample space would be what actually occurred. So, computing empirical, a single die is rolled twice. There are 36 equally likely outcomes as shown below. Find the probability of getting two numbers whose sum is greater than 7. Okay, so these are all the rolls, and you're finding the sum. So, probability that the sum is greater than 7. So, I would look at all the rolls and circle the ones that have a sum greater than 7. On that, give me 8 or 9 or 10. So all of those outcomes are outcomes that give us a sum of greater than 7. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 15 out of the 36. So we simplify that. I could reduce by 3. So 5, 12. Okay, and then our last problem is find the probability of getting two numbers whose sum is 8. The probability that the sum equals 8 now. So exactly 8. 1, 2, 3, 4, 5 out of the 36. And we can't reduce that.